Hello.
Yes, yes,
Uh,
sir. Hello.
Hi, sister. Are you able to hear me? Hello.
Yes, sir. I can hear you.
Okay then. Okay. Yeah. So I'll start right now. Okay. So as discussed, we'll start with circular motion, isn't it? Yeah. It's been a long time. Uh, Means like my hands with this writing pad is getting slower day by day. Today is date 38th November.
Your part is like getting cut off.
हाँ हाँ हाँ
ऊपर वाला part that is getting cut off थोड़ा सा.
थोड़ा सा अच्छा वो मैं ऊपर से छोड़ के ही लिखूंगा, टेंशन ना लो, है ना? बस ऐसे ही हेडिंग मैंने लगा दिया है ना। अच्छा, एक मिनट, वन मिनट, दैट इज द अपोजिट स्क्रीन, वेट वन मिनट, आई विल शेयर द स्क्रीन। ओके, दैट इज वर्चुअल कैम which is on. Okay, now you pin that this slide. Okay, this, there will be two things. In one there will be like written opposite, and another one it will be perfectly clear like circular motion. You just click on that, just pin that presentation one, not the meeting one. Okay, now now you got it.
Yeah,
Now it is perfectly visible, the full screen.
yeah,
Yeah.
yeah.
Okay then. So we'll start with basic properties. Then I'll move ahead. Are you able to get me or not? Okay. So I'll not stress that much on theoretical and all those kind of approach, but little bit I'll just take your way and then I'll move. Okay. So basically, in kinematics, when we have kinematics, and this is our circular motion. Okay. So we'll try to understand what are the differences and what are the basic things. One minute, let me just this. Okay. Yeah. So what are the basic equations in kinematics and what are the basic equations in circular motion? We are going to do that and then I'll move ahead. Okay. So you know that in kinematics we have position, then velocity.
Should I write all this?
Uh-huh.
Should I write all this?
I'll tell you when to write. Okay. I'll tell you. I'll share the slides with you. Okay. So position, velocity, and acceleration. Okay. So this is our uh, displacement or position. Basically, I'll write position. Okay. And then we have V as velocity. You know that. And then we have A as acceleration. Now, these all quantities changes to three different kind of quantities called as theta, omega, and alpha. Are you able to get me or not? Where theta is called as angular. Are you able to get me or not? While omega is called as angular velocity and alpha is called as angular acceleration. Correct. Okay. So basically these all three quantities. Now one of the property of these three are they are all vectors, while here they are also vectors. Are you able to get me or not? Okay. So one of the properties that these vectors are kind of normal vectors. They can take any kind of form or any kind of like any kind of particular direction in the form of I, j, and k cap. Is this clear or not? But these vectors have one special kind of form. They are known by a name of axial vectors. Why we call it as axial vectors? Because the direction of theta, omega, and alpha. Let's suppose if there is a circle, if the body is performing a circular motion, are you able to get me or not? Means there is a body which is located at radius r, okay, and this is performing a circular motion with some kind of angular velocity omega. Then the direction of this omega depends upon how you actually rotate it. If you rotate it anti-clockwise, Then do you know the right hand thumb rule, no?
Yeah.
Yeah, so try to put your fingers along the direction of arrow, and then the thumb will try to point out where this particular omega will be. So if I rotate it, if I put
Yeah.
my thumb, then if I put my fingers like this, then the thumb will point outwards for this particular kind of rotation, isn't it? So basically, for this, the omega is in the direction of outward. Are you able to get me or not? So basically, why I call them axial vectors, because their direction depends upon right hand thumb rule. Okay. Okay, all these things means basically you can say that if the body is doing some omega, then it will travel, it will do some angular displacement theta. So then theta will also have the same direction as omega. Are you able to get me? And similarly, alpha will also have the same direction as omega. Is this clear or not? So they have always they follow this particular rule, right hand thumb rule. So their direction is determined by the thumb. Are you able to get me or not? Okay. Now, if we go to the main equations, then
What do you mean by axis vector?
because that is what it is saying. Because see, if I want to rotate these objects, then I need to keep one axis at the center, and then I try to rotate it, then I'll have to rotate it or not.
Right.
And thumb is directly pointing towards that direction of axis, no? So that's why we call them as axial vectors. Are you able to get me or not? So like I'll just show you like this. If this is a body performing any kind of circular motion, okay. So for this will be the axis, isn't it? If the body is doing
Yes, of course.
any kind of circular motion like this way with angular velocity omega, are you able to get me or not? So this thumb,
Yeah.
basically the direction of omega is towards this side. The displacement, let's suppose the particle move from here to here with some kind of angular displacement. The theta is also towards
Yeah.
this side only. And if the body is having some angular acceleration alpha, the alpha is also having a direction towards this particular kind of axis. That's why they are known by the name of axial.
Axial vectors.
Are you able to get me? Is this clear or not?
Yes.
Okay, then we tell that all this quantity have a dependency on each other. Like in kinematics, we have acceleration is equal to final velocity minus initial velocity by time taken, isn't it? And
Uh-huh.
similarly, displacement was measured by s is equal to ut plus half at square.
Half at square.
Then we have the velocity square is equal to u square plus 2as. All these three quantities, basically I'm just doing the digression, okay? So it's a kind of
Yeah.
quick revision, okay? So all these three quantities interchange into the circular motion equation. A changes to alpha, and this V changes to omega final, U changes to omega initial divided by time taken. Are you able to get me or not? So this is the equation of angular acceleration. Next thing, if I talk about displacement, displacement changes to theta, and then once again omega initial into time t plus half alpha t square. Okay,
Yeah. Half alpha t square.
where t remains as it is. Remember that. Are you able to get me or not? So v final will be
Yes.
changed to omega final square is equal to omega initial square plus twice alpha into displacement theta. So these all are those kind of circular motion equations which governs the circular displacement and all those kind of things. Are you able to get me or not?
Yes.
Okay, so these are the basic properties which we follow. Okay, and based upon that only, I'll try to make you understand what are all those things. Okay, so now relations of these kind of quantities. Okay, so then the question starts that can we relate our kinematics with this circular motion or not? Is it possible? The answer replies that there is an answer for that. Yes, we can relate it. Are you able to get me or not? Then the question arises how?
Yeah.
So first we'll look into the circular motion equations only. Then we'll jump on
Yeah.
to different kinds of properties. Are you able to get me or not? So look over here.
Yes.
Basically, if I look into circular motions relation, omega is nothing but as it is d theta by dt. Are you able to get me or not? Just like in kinematics, we have velocity is equal to dx by dt, omega is equal to d theta by dt. Similarly, we know
Uh-huh.
acceleration is equal to dv by dt, and then there is another form that is d2x by dt square. Are you able to get me or not? So similarly, alpha
Okay.
is related over here, like it is. d
d omega by
dt, and also it can be written as
or d is equal theta
by,
by d square.
yeah, you have to remember that this is d2 theta, not, you do not have to say d square. Are you able to get me or not? Never say d square, okay? So that is d2 theta by dt square. Are you able to get me or not? That's the way of correct pronunciation. Okay, now as we know that I can go through the reverse of this, so I can find my theta, but that must be integrated through finding omega with respect to dt. Are you able to get me or not? Similarly, I can find omega, but that must be taken with alpha dt. Are you able to get me or not? Now these integrations depends upon initial condition also. Okay,
Yeah.
like why I wrote initial condition, because see, this is theta is equal to omega dt, but I can have also at t is equal to 0 some initial displacement or not, or some initial velocity or not. So that is why when I will
Yeah.
write those equations in terms of initial conditions, then the equation little bit optimizes, and it is written as theta final minus theta initial is equal to omega dt. Are you able to get me or not? And then,
So yeah, so it will basically put those limits
या
around.
या सो उसमें थोड़ा सा ऑप्टिमाइज कर देंगे हम, आर एबल टू गेट मी ऑन, सो ओमेगा फाइनल माइनस ओमेगा
Optimization.
ऑप्टिमाइज,
Optimization.
ऑप्टिमाइज मतलब देखो जैसे मतलब जैसे तुमने ओमेगा दे दिया और ओमेगा को लिख दिया कि इन थीटा निकालो, तो हम टी इज इक्वल टू जीरो पे कोई ना कोई एक इनिशियल डिस्प्लेसमेंट भी तो हो सकता है ना, पॉसिबल।
हाँ, हो सकता है
हाँ, तो जब हम उस इनिशियल डिस्प्लेसमेंट को कंसिडर करेंगे, जब हम यहाँ पे t इज इक्वल टू जीरो कर देंगे और t तक इंटीग्रेट करेंगे, और यहाँ पे भी जीरो से लेके t तक इंटीग्रेट करेंगे, तो इस जीरो की वैल्यू अगर जीरो हुई तो थीटा इनिशियल की वैल्यू क्या हो जाएगी? जीरो। लेकिन अगर जीरो नहीं हुई तो ये
हाँ।
थीटा इनिशियल इस जीरो के लिए उस टाइम पे जो भी पॉसिबल वैल्यू होगा उसको पिकअप करेगा। आर यू एबल टू गेट मी और नॉट?
Yeah.
Okay, I'll give you the numericals, and based upon that you can understand in much more perfect way. Similarly, over here also,
Yeah.
if omega initial at 0 is 0, it will be 0. But if it is some value, then it will take that particular some value. Are you able to get me?
Yes.
Okay, so this is, that's why I told you that it depends upon initial condition. Like what is the initial condition given to you, whether it is 0 or not, whether it is a positive number or whether it is a negative number. All these things depends upon that particular kind of quantity. Are you able to get me or not?
Yes.
ठीक है ना? तो basically we are going to move, we are going to do this, we are going to understand this in that particular sense, and we'll move ahead with this. Okay, now अब ध्यान से देखो, मतलब ये सारी इक्वेशंस हो गए, इससे ऊपर मैं क्वेश्चंस कराऊंगा, एक बार मैं सारे इक्वेशन डाइग्रेस करके फिर मैं क्वेश्चन कराऊंगा। आर एबल टू गेट मी और नॉट? ठीक है।
Yes.
तो अब देखो, अगर मान लो कोई बॉडी सर्कुलर मोशन को एग्जिबिट कर रहा है ना, वन मिनट, लेट मी ड्रॉ परफेक्ट सर्कल। ठीक है, तो कंसिडर दैट दिस बॉडी इज डूइंग अ परफेक्ट सर्कुलर मोशन in which the radius of that circular path is capital R. Are you able to get me or not? Then this
Yes.
body will have some omega with which it will rotate along this particular circular path or not. And then what
Yes.
it, what it will do, that this omega will make the body to shift some angles, and that angle will be created as theta. Are you able to get me or not? So that theta can be
Yes.
directly written as omega into time period t if you know your time of
Yeah.
trapping. Are you able to get me or not?
Yeah. Distance is equal to scale
Yeah,
and
distance.
distance.
Yeah, are you able to get me? So now
Yes.
the basic thing is theta we can calculate. Theta can be known to us. But what is not known to us is omega. Mainly we will get to know about omega in a much more greater sense. So देखो, so the main thing is, now the things start. One thing is called as angular velocity. Are you able to get me or not?
Yes.
ठीक है, तो ये सारे इक्वेशंस हो गए। इन सारे इक्वेशंस को एक साथ जब हम पकड़ते हैं तो सबसे पहले जो टॉपिक आती है, खुद ये सोचना कि ये एंगुलर वेलोसिटी है क्या, जिसकी हम डिनोशन करते हैं ओमेगा से। आर यू एबल टू गेट मी और नॉट? तो हमें
Yeah.
काइनेमेटिक्स में पता था कि काइनेमेटिक्स में वेलोसिटी होती है, क्या होती है वेलोसिटी, जो बॉडी को, लेट्स सपोज बॉडी डिस्प्लेसेस, ये मान लो एक कार है, ठीक है, अगर ये कार किसी वेलोसिटी से यहाँ मतलब t इज इक्वल टू जीरो से लेके यहाँ पर आके पहुंच जाता है ना, एट t इज इक्वल टू टाइम t, तो हम बोलते हैं कि बॉडी कुछ ना कुछ डिस्प्लेसमेंट पावर की है विद रिस्पेक्ट टू दिस पर्टिकुलर velocity. Are you able to get me or not? If velocity changes, then acceleration will be present. So right now we are not considering any kind of change. We are just considering velocity. ठीक है? तो हम अगर एक सर्कुलर path को consider करें, if I just consider one particular kind of circular path, means whatever you wanna consider. Let's suppose I have any kind of circular path whichsoever you want. Okay, so this is my circle and the body is performing circular motion. Okay, so इसका कोई ना कोई एक रेडियस होगा, ठीक। तो जब बॉडी यहाँ से लेके यहाँ तक मूव करेगी, तो यहाँ पे इस टाइम के ऊपर इस बॉडी के पास भी तो वेलोसिटी होगी ना, होगी। देखो, ठीक है, तो अभी हम टेंजेंशियल पे जाएंगे नहीं, अभी हम बताऊंगा क्या किस तरह की वेलोसिटीज पॉसिबल है। बट बॉडी तो ओमेगा के साथ रोटेट भी कर रही है ना। यस, तो देखो ध्यान से देखो, तो बॉडी के पास वेलोसिटी भी है, ओमेगा भी है, रेडियस आर भी है। तो बेसिकली दिस ओमेगा इज ट्राइंग टू जनरेट माय वेलोसिटी और नॉट। बेसिकली अगर बेसिक तुम खुद सोचो, मतलब इस ओमेगा की वजह से ही उस पार्टिकल के पास वेलोसिटी आ रही है ना। अगर तुम फैन की स्विच मतलब इमेजिन कर सकते हो कि जैसे कि फैन है, ठीक है, ये अपन का एक फैन हो गया, ठीक है, मान लो ट्रिपल ब्लेड्स वाला, ठीक है। तो जब तक तुम इस स्विच को ऑन नहीं करोगे, स्विच ऑन करेगा करोगे तो क्या करेगा, ये जो मोटर है एक ओमेगा जनरेट करेगा। उसके बाद ये एक सर्कुलर मोशन एस्टैब्लिश होगा ना यहाँ पे, बोल हाँ या ना। Yes. So the question arises is that I need to think about first omega, which is going to generate my v. But the question arises how? तो देखो, ये ओमेगा जो होता है बेसिकली इसीलिए हम लिखते हैं कि velocity is created by omega which tries to rotate my radius. बोल, are you able to get me or not? कि जो भी ओमेगा है, ओमेगा इज नथिंग बट इट इज दैट पर्टिकुलर rotational speed which is trying to generate the velocity at each and every point of the part of the particle on this particular circular path. Is this clear or not? मेरी बात समझ में आई या नहीं आई? कि ये जो ओमेगा है ना, वो कुछ नहीं कर रहा है। ओमेगा क्या कर रहा है, हर पॉइंट पे वेलोसिटी को जनरेट कर रहा है। अब तुम खुद देखो, ओमेगा इज ट्राइंग टू रोटेट, बेसिकली इट इज रिटन एज आर क्रॉस ओमेगा। आर यू एबल टू गेट मी और नॉट? But the question arises, what's the meaning of that? This is nothing but it is saying that omega is trying to rotate my radius, and due to that, my velocity is created. Are you able to get me? मेरी बातें समझ में आई? आई थिंक इट इज आर क्रॉस ओमेगा और ओमेगा क्रॉस आर। यू विल हैव टू चेक इट वंस, ठीक है, एक बार देख लेना, ठीक है। तो बेसिकली इट इज नथिंग। आर क्रॉस, हाँ मेरे को, हाँ मेरे को भी वही लग रहा है, इट इज आर क्रॉस ओमेगा, ठीक है ना। तो बेसिकली जब भी हर पॉइंट पे जब भी हम वेलोसिटी को जनरेट करेंगे, इट इज आर क्रॉस ओमेगा। इज दिस क्लियर और नॉट? मेरी बात समझ में आई या नहीं आई? एंड दिस इज कॉल्ड एज द रिलेशन बिटवीन वेलोसिटी, रेडियस एंड ओमेगा। तो बहुत लोग ऐसे पढ़ते हैं, वेलोसिटी v इज इक्वल टू ओमेगा आर, या आर ओमेगा ऐसे करके पढ़ते हैं। आर एबल टू गेट मी? ठीक है, चलो तो कैन आई मूव अहेड? ठीक। तो बेसिकली इससे सबसे ज्यादा इंपॉर्टेंट है कि जब भी हम वेलोसिटी लिखें, तो वेलोसिटी अगर हम मैग्नीट्यूड फॉर्म में लिखेंगे तो इसको हम लिख सकते हैं ना, v इज इक्वल टू आर ओमेगा साइन थीटा। यस, बेसिकली हम उस यूनिट वेक्टर को भी हटा दे रहे हैं, मतलब हम सिर्फ मैग्नीट्यूड के फॉर्म में लिख रहे हैं। आर यू एबल टू गेट मी और नॉट? Okay, so basically omega can be defined as what? Either it is V by R sine theta. It will be V by R sine theta or not. But whenever you think of a radius, whenever this is radius, and if I think of sine theta, if this is angle theta with at any point of time, are you able to get me or not? This is, हाँ, so basically R sine theta is nothing but it is the perpendicular component or not. So basically I can write it as velocity by r perpendicular, है ना। लेकिन एक चीज ऐसी भी तो मानी जा सकती है ना कि मान लो अगर मैं इस वेलोसिटी को देखूं और ये एंगल अगर थीटा है, ठीक है, ये वेलोसिटी किसी और डायरेक्शन में थी, ठीक है, तो basically try to think, try to imagine, okay, if this velocity was in this particular direction, then if this is angle theta, this angle must be also equal to theta or not? Why? Because they are trying to generate a particular, means we have the velocity creating angle theta with the radius also, it can be also possible. Are you able to get me or not? So then this velocity v by sine theta is what? Basically v by sine theta will be nothing. 1 minute. I think this will appear as 90 minus theta. 1 minute. This is theta. Yeah. So something like that. Yeah. So basically, if I think of V over here, so this is going to be my 90 degrees, okay, and this is theta, this is 90 minus theta almost. So basically हम ऐसे सोच सकते हैं कि V by sin theta एक ऐसा component होगा जो कि रेडियस पे भी तो परपेंडिकुलर हो सकता है ना? आर एबल टू गेट मी और नॉट? मतलब देखो, या तो हम v बाई आर साइन थीटा को परपेंडिकुलर मान लें, कभी भी कोई भी दो चीजें पॉसिबल हो सकती है। मान लो अगर ये एक स्ट्रेट लाइन है, ठीक, और इसके साथ ये एक सेकंड लाइन हो गया, ये मान लो ए हो गया, ये मान लो बी हो गया, इनके बीच में एंगल कितना है? थीटा। तो जब भी हम ए कंसिडर करें तो इस ए के दो कंपोनेंट हो सकते हैं, या तो इस डायरेक्शन में होगा ए कॉस थीटा, है ना, या फिर इसका परपेंडिकुलर कंपोनेंट है कि नहीं, ए साइन थीटा। और दूसरी बात क्या हो सकती है कि इस बी का भी तो कंपोनेंट हो सकता है ना, इधर हो गया बी कॉस थीटा, और इसका परपेंडिकुलर कंपोनेंट क्या हो सकता है? बी साइन। आर एबल टू गेट मी और नॉट? बट देन, हाँ, मतलब अगर डिनोमिनेटर ऐसा, अभी हम वो मतलब उस पर्टिकुलर कंसिडरेशन को नहीं कंसिडर कर रहे हैं, मींस कंसिडरेशन ऑफ पर्टिकुलर एंगल एंड समथिंग लाइक दैट, negative or positive sign. Just I'm trying to make you understand that what can be the perpendicular component and what can be the horizontal component. Are you able to get me or not? तो मतलब अगर कोई भी दो क्वांटिटीज है, उनके बीच में कोई भी अगर एंगल थीटा है, तो उनके पास दो कंपोनेंट बन सकते हैं। ये कंपोनेंट अभी क्या आ गया? बी साइन थीटा। अब बी साइन थीटा को तुम सोचोगे कि अगर हम परपेंडिकुलर लें या कुछ भी लें, तो बेसिकली दिस अपीयर्स, दिस v by sin theta appears as velocity perpendicular on this particular radius. I'll show you some 3D diagram one day, okay? So there you can understand it much more perfectly. So basically omega can be written as either v by r perpendicular or v perpendicular by r. Are you able to get me or not? दोनों लिख सकते हैं। आर यू एबल टू गेट मी? मतलब कंसिडरेशन क्या करना है कि आप तो जब वेलोसिटी कंसिडर कर रहे हो तो आर परपेंडिकुलर कंसिडर कर लो तो ओमेगा मिल जाएगा, या फिर जब वेलोसिटी परपेंडिकुलर कंसिडर करोगे तो अगर तुमने रेडियस कंसिडर किया तो वहां पे सिर्फ वेलोसिटी परपेंडिकुलर कंसिडर करना पड़ेगा। मतलब दोनों साइमल्टेनियसली पॉसिबल है। या तो तुम ये मान लो रेडियस है और ये मान लो वेलोसिटी है ना, तो या तो तुम वेलोसिटी की परपेंडिकुलर कंपोनेंट ड्रॉ करो रेडियस के ऊपर, या फिर अगर ये वेलोसिटी है, अगर ये रेडियस है, तो रेडियस का परपेंडिकुलर ड्रॉ करो। आर यू एबल टू गेट मी और नॉट? और बात क्या आएगा, दोनों से सेम आएगा। इज दिस क्लियर और नॉट? टोटली क्लियर ना? ठीक। तो दिस इज हाउ ओमेगा इज डिफाइंड। ओमेगा इज नथिंग बट, वी मेनी टाइम्स calculating r perpendicular is kind of tedious with respect to velocity, so हम हरदम कंसिडर करते हैं velocity perpendicular on by radius. Are you able to get me or not? ठीक। अब देखो, अब इससे इससे इतनी ज्यादा समझ में नहीं है, इससे थोड़ा सा मतलब एक फॉर्मूला टाइप आंसर मिला है ना, लेकिन हम एक ऑब्जर्वेशन करेंगे, है ना, एक ऑब्जर्वेशन को कंसिडर करेंगे और उस ऑब्जर्वेशन के थ्रू हम आगे बढ़ेंगे, ठीक है? उससे तुम्हें मालूम चलेगा कि ओमेगा का सिग्निफिकेंस क्या है। अब क्वेश्चन एक बार पूछा गया कि क्या सर्कुलर मोशन होना जरूरी है ओमेगा की प्रेजेंस रहने के लिए? चलिए, is circular motion is necessary? Thus the body is required to rotate if to find or to get the omega. Mm-hmm. टेल मी, इज इट नेसेसरी? अब देखो इस ऑब्जर्व, अच्छा मान, ओके अच्छा एक ऑब्जर्वेशन को समझो। मान लो या मान लो यहाँ पे एक कैमरामैन खड़ा है, ठीक है, मतलब मान लो कोई एक पर्सन यहाँ पे खड़ा है, ठीक है, लेट्स सपोज अ पर्सन इज स्टैंडिंग, मतलब वो जो केटीएम वाले छपरी गाय होते हैं ना वो खड़े हैं, है ना? ठीक। और हाँ कैमरामैन, और सामने से कार में, मान लो ये कार हो गई लैम्बोर्गिनी गलाटो, लैम्बोर्गिनी के अंदर एक कैटरीना कैफ पार हो रही है। दुबई में कैटरीना कैफ हरदम देखी जा सकती है ना? ठीक है। तो अब मान लो ये जो कैमरा मैन है वो कैसे नोटिस करेगा? देखो एक बार ये इसके सामने से ऐसे गुजर रही है, मान लो एक रोड है और ये कैमरा मैन यहाँ पे फिक्स्ड है। आर यू एबल टू गेट मी और नॉट? तो एक बात बताओ, जैसे जैसे ये कार आगे बढ़ेगा, अगर इस पर्टिकुलर कैमरा मैन को कैटरीना कैफ की फोटो लेनी है, तो वो अपना सर यहाँ से लेके ऐसे गोल घुमाएगा या नहीं घुमाएगा, बताओ जरा? घुमाएगा ना? तो जैसे ही गोल घुमाया, बेसिकली कार तो स्ट्रेट लाइन मोशन में चल रही थी, लेकिन पार्टिकल को क्या करना पड़ा, सर घुमाना पड़ा ना, ताकि कार को पूरी तरह से ऑब्जर्व कर पाए। तो क्या यहाँ पे सर के हिसाब से एक ओमेगा क्रिएट हुआ या नहीं हुआ? हुआ ना? तो दैट इज व्हाट आई वांटेड टू मेक यू अंडरस्टैंड, ओमेगा इज नथिंग बट अ ऑब्जर्वेशन। ओमेगा एक ऐसी वेलोसिटी है, वेलोसिटी ऑब्जर्व बाय द ऑब्जर्वर with respect to a line joining the observer and the particle। ओमेगा कुछ नहीं है, ओमेगा वेलोसिटी ही है, ठीक है, बट इसमें जो ऑब्जर्वर है ना, वो क्या करता है, वो पार्टिकल को ऑब्जर्व करने की कोशिश करता है, और जैसे ही ऑब्जर्व करता है उस समय मालूम चल जाता है कि ओमेगा है या नहीं। तो बेसिकली इसीलिए एंगुलर वेलोसिटी को हम बोल सकते हैं कि इट इज ऑब्जर्वर डिपेंडेंट, है या नहीं, है या नहीं है ना? क्योंकि जैसे जैसे ऑब्जर्वर का सर घूमेगा वैसे वैसे ओमेगा दिखेगा या नहीं दिखेगा? आर यू एबल टू गेट मी और नॉट? तो बेसिकली मेनी पीपल से ओमेगा is defined for a straight path or particle moving in circular motion. The answer is no. It can be present for any kind of a straight path also. Are you able to get me or not? Just you have to define your observer. Are you able to get me? मतलब ओमेगा कैन बी इवन पॉसिबल विद रिस्पेक्ट टू स्ट्रेट पाथ, बट हमें डिफाइन वहां पे क्या करना होगा? ऑब्जर्वर को डिफाइन करना होगा। क्या डिफाइन करना होगा? ऑब्जर्वर को डिफाइन। ठीक है। तो बेसिकली सिंपल सी बात है, लास्ट पॉइंट, कि सिर्फ सर्कल, अगर सिर्फ सर्कल हो, ऐसा नहीं है कि सिर्फ सर्कल में ही तुम्हें ओमेगा मिलेगा। बेसिकली सर्कल में जो ओमेगा है वो किसी एक पर्टिकुलर ऑब्जर्वर के रेस्पेक्ट में, किसी एक एक्सिस के रेस्पेक्ट में डिफाइन होती है। आर यू एबल टू गेट मी और नॉट? तो दिस ओमेगा इज मेजर्ड विद रिस्पेक्ट टू अ पॉइंट, नॉट एन लाइन। I'll tell you, I'll tell you. See, are we defining this omega with respect to this particular arc over here? No, na. We are defining with respect to this center over here or not. But center is a point. So how we define omega? We are defining with respect to a point, not with respect to a line. Are you able to get me or not? That's the third important property of omega. Is this clear? Where omega is nothing but velocity perpendicular on my radius. Is this clear or not? Are you able to get me? Totally? ठीक है, इसको लिख लो फिर अपन आगे बढ़ते हैं। ठीक है, 1 minute, let me just see. I have to check HCR mounts, that is omega cross r cross omega, it is omega cross r, I think so. R cross omega, I think it is r cross omega only, isn't it? Okay, almost I picked this many times back. एंगुलर वेलोसिटी ये अपन ने कंप्लीट कर लिया, ये सारी चीजें है ना। और ओमेगा 2 पाई r/t। अच्छा, तुम लोगों ने तुमने सेंट्रीफ्यूगल फोर्सेस वगैरह ये सब पढ़ा है ना।
हाँ पढ़ा है।
ठीक है फिर done। उसके ऊपर थोड़ा सा अपन बात करेंगे, ठीक है, और उसके बाद आगे बढ़ेंगे, है ना। तो अपन ऐसा नहीं है कि एकदम लास्ट तक पहुंच जाएंगे, बस आई ट्राई टू बी मच मोर प्रिसाइज ड्यूरिंग दिस पर्टिकुलर डिस्कशन, ओके। और ये सारे इससे हमारे क्वेश्चंस तुम करके बताओगे मेरे को, है ना, कि कैसे बना रहे हो कैसे नहीं बना रहे हो, इज दिस क्लियर और नॉट। ठीक है, और मतलब हर क्वेश्चन का ट्राई करना कि तुम सॉल्यूशन प्रोवाइड करो मेरे को, ठीक है, क्योंकि आई विल सी वेदर यू आर डूइंग परफेक्टली और नॉट, ठीक है। हाँ, बिकॉज एचसीबीएम में ऐसा है कि हम आंसर तो लेकर आ जाते हैं, बट बहुत सारे आंसर ऐसे होते हैं जो एकदम से अलग होते हैं, ठीक है चलो, इज क्लियर और नॉट। तो अपना अपना जो वे है ना वो शो करना मेरे को, बिकॉज एचसीबीएम इज दैट पर्टिकुलर थिंग व्हिच आई वांट टू सी हाउ यू आर डूइंग, ओके। देयर आर मेनी क्वेश्चंस व्हिच आर वेरी वेरी इंपॉर्टेंट, ओके। चलो, कैन आई मूव अहेड विद दिस।
Yes, yes.
Okay, so I'll bring some questions, but little bit I'll just last point I'll digress. So you got to know that I have to always take on consideration of omega as v perpendicular on my radius. Are you able to get me or not? So
Yes.
based upon that, we'll try to move ahead. Okay, so let's say let us do one thing. I'll start giving one or I'll give two examples, not more. Then you tell me. Okay, so here is my observer. This time the observer is over here. Okay, this is my observer. Okay.
Observer also like this is my axis.
No, no, no. Observer is sitting over here. This is the two paths. Okay, and the observer is sitting over here at a distance of, let's suppose, from here to here it is almost around, consider it to be 40 meters. How much? 40. Okay, and then a car starts from here with some velocity v is equal to 10 meter per second. How much velocity? 10 meter per second in this particular direction. But this distance is 30 meters. Is this clear or not? Then
हाँ
the
clear.
question is find the omega. Now, if observer will observe, what he will feel? That car is going forward and his head will once again turn or not. If his head
It will turn.
turn, then omega has been created or not. So the question is
Yes.
find omega at omega of car with respect to observer at that instant.
ठीक है.
ठीक है, बताओ, जल्दी बताओ, यू हैव 2 minutes ऑफ टाइम।
So it is V perpendicular as in
अच्छा, फर्स्ट यू हैव टू थिंक अबाउट रेडियस और नॉट।
yeah
Yeah.
radius is
So what is going to be the radius according to your imagination? अच्छा, can I say that
उनका
radius
so
is,
उनका जो inclined yeah 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 Pythagoras theorem use करके you will get the radius.
basically radius is nothing but the line joining the observer and this particular cat or means car or. If
Yeah
this is
yeah
40, this is 30, so this will be almost 50 meters,
50 50 होना.
isn't it? So we have got our radius. This is my radius, and this is the direction of velocity. Okay, so this is my velocity, 10 meter per second. This is my radius, 50 meter. Are you able to get me or not? To find omega of car with respect to observer, I need velocity perpendicular on my radius or not. Then, do I need to know this particular angle over here or not? If that, yeah, so is that angle will be nothing but this vertically opposite angle. तो मतलब अगर हमें ये एंगल पता है तो बेसिकली आई नो दिस थीटा और नॉट. So do you know about something called as uh, 37-53 degree rule? I'll just do this. I'll just make you remind it. If this is 37 degree, then opposite side of there is 3, 4 and 5. Right or not? And this side is 53. Yeah. So here we have 4 and here we have 30 or not. So that is almost 4 by 3. So this angle must be exactly equal to 53 degree or not. Are you able to get me? So this theta is equal to how much? 53. And then this velocity will have two components, v cos 53, and the perpendicular component will be how much? V sin 53. Are you able to get me or not? So basically omega will be how much? V sin 53 divided by how much? Radius. Radius is nothing but how much? 50 meter. Yeah. So omega V is 10, but sin 53 is how much? Sin 53 can I find? 5. Yeah. So 4 by 5 means 5 by 50. So 5 twos are 10, 2 is 25. So this is how much? 4 by 25 rad per second. This is your omega over here. Are you able to get me or not? Understood? Yeah, I'll definitely. Yeah, yeah. मैंने क्या बोला कि ऑब्जर्वर के सामने एक कार चल रही है जिसकी रफ्तार कितनी है 10 मीटर पर सेकेंड एंड दिस डिस्टेंस इज 30 मीटर दिस डिस्टेंस इज 40 मीटर आर एबल टू गेट मी और नॉट सो to find omega we need velocity perpendicular on my radius or not. What is radius then? It is a line joining the observer and the particle. Are you able to get me? So if I join that line, if I just create the line between observer and the particle, that length will be how much? 50 meters. Are you able to get me? Then this velocity is 10. So I need to find that what is the perpendicular component of this particular velocity over here or not. To find that particular component of velocity, I need to know that what is the angle it is making with the radius. To find that angle, I created this vertically opposite angle, which will tell about me that what is the theta, and then I can know the perpendicular velocity component. Are you able to get me or not? Now here it is an unorthodox length like 30 by 40. But to find that unorthodox length, there is a particular combination that if I have 37, the opposite side is 3, 4 and 5. And ये अगर 53 हो गया तो उसका opposite side 4, 5 और 3 से rotate करता है. Are you able to get me or not? तो बस अपने velocity के दो component एक radius के direction में दूसरा perpendicular direction में. बस तो ओमेगा मिल गया ना v sin 53 by 50. Is this clear or not? मेरी बातें समझ में आई? कैन आई मूव अहेड? ओके, एक और क्वेश्चन दूं या फिर आगे बढ़ो, टॉपिक पे बढ़ो? ओके, should I give a little bit tricky one? ठीक, चलो, या ठीक है. अब देखो मतलब एक पर्सन है, मान लो वो तुम इंडियन सीरियल्स देखे हो ना, है ना? अरे कोई भी इंडियन सीरियल उसमें जिसमें ऊपर से एक लड़की नीचे गिर रही होती है और रूफ टॉप से, है ना? और नीचे से हीरो दौड़ता है कैच करने के लिए, है कि नहीं? तो यहाँ पे वही सीन है कि एक बॉल जो है ना ऊपर से नीचे गिर रहा है, ठीक है? एंड द बॉल वाज एट हाइट ऑफ 50 meters राइट नाउ. ठीक है, ये जो हाइट दी गई है बॉल की, ये कितनी दी गई है? 50 मीटर्स।
50।
ठीक। तो बोल रहा है कि दिस ऑब्जर्वर इज स्टेशनरी। ऑब्जर्वर है यहाँ पे, कैसा है बेटा? स्टेशनरी मतलब खड़ा है यहाँ पे, कुछ नहीं, हिल डुल नहीं रहा है। तो क्वेश्चन पूछ रहा है कि फाइंड द ओमेगा ऑफ बॉल with respect to observer after 2 seconds। ठीक है, और बॉल यहाँ से रिलीज किया जा रहा है। ठीक है, वेयर द ऑब्जर्वर डिस्टेंस फ्रॉम दिस पॉइंट इज ऑलमोस्ट अराउंड जस्ट 40 मीटर्स। बताओ क्या है?
अच्छा,
हम्म,
तो पहले रेडियस को फाइंड आउट करना है ना।
पहले तो रेडियस के बारे में ही सोचना है।
कहाँ
दिमाग लगाओ।
सोचेंगे? वो उसका इंक्लाइन वाला होगा।
सोचो क्या होना चाहिए।
पहले तो रेडियस को फाइंड करना है। वेट।
यू विल गेट 2 minutes of time. Till that, I'll check on Google once whether it is R cross omega or omega cross R. Still, I'm over there. Hmm. Yeah, it is omega cross R, not R cross omega. They are appearing, that's appearing due to the cross product. Okay. In rotational, I'll tell you how it appears. Okay. Or tomorrow by a diagram, I'll represent it. I do not have that 3D diagram. Okay. This appears due to 3D diagram. You can visualize this that V is equal to omega cross R. Okay. Not R cross omega. Because look over here, omega's direction is in which direction? Let's suppose if it is rotating in anti-clockwise, so omega is in direction of k cap. Are you able to get me or not? And then r
Yeah.
is along the direction of I cap. So if I
Yeah.
take I cross k, that is minus
Minus
j. That means
minus j
velocity
cap.
will be downwards. But is velocity is downwards? No. So
नहीं.
that means what? What I have actually basically k cross I cross k. K cross I, then only I'll be getting J cap. So that means omega cross R. ठीक है, उसे कुछ दिक्कत नहीं है, जस्ट इट्स अ वे ऑफ रिप्रेजेंटेशन ऑफ क्रॉस प्रोडक्ट, माइनस साइन आ जाता इफ आई विल इंक्लूड आर क्रॉस ओमेगा। ओके,
Yeah.
बताओ ये क्वेश्चन का आंसर क्या होगा? फाइंड द ओमेगा ऑफ बॉल विद रिस्पेक्ट टू ऑब्जर्वर आफ्टर टी इज इक्वल टू 2 सेकेंड्स। बनेगा या बताओ, कुछ हिंट दो। जस्ट सोचो जरा, ये जो बॉल है 2 सेकंड बाद ये कुछ डिस्टेंस ट्रेवल करके नीचे आ जाएगा ना।
हाँ.
ठीक, तो ये जो हाइट इंपॉर्टेंट निकालना जरूरी है या नहीं है, कि हाउ मच हाइट द बॉल हैज फॉलन इन टाइम टी इज इक्वल टू 2 सेकेंड्स।
अच्छा.
आर यू एबल टू गेट मी? सो यू हैव टू फाइंड,
Why?
Uh-huh.
Exactly.
Why? Because I'm not asking that omega of the ball at initial case. I'm asking omega of ball with respect to our observer at t is equal to 2 seconds. Are you able to get me or not? So when you
Yeah.
want to define at t is equal to 2 seconds, the ball will come down or not. So it will travel some height in t is equal to 2 seconds. The ball will be over here. Then I'll join the observer with the ball at this point of time. And this is my radius now. That particular line is not my radius. Are you able to get me or not?
Ah.
So what is my height then? Height is nothing but how to find height. Height is what formula? I'll use the displacement equation. I do not remember anything. So I am a normal guy. I'll use S is equal to ut plus half it is. But displacement is height h. Initial is 0. Time is 0. At sorry, time is 2 seconds. And this height is in downward direction or not. So it must be always
Downward.
negative. Are you able to get me or not?
Negative. I mean, it's up to us if we can take negative or
No,
positive.
just consider negative. Downward, if you are studying from me, downward, negative, upward, positive, right, positive, left, negative. That's all. That's our sign convention, nothing else. Will be utilized everywhere as same. Okay. Huh. So now acceleration, it will fall with respect to acceleration due to gravity, isn't it?
Yeah.
एक्सेलरेशन ड्यू टू ग्रेविटी से कौन करेगा तो ए की वैल्यू क्या होगी माइनस जी होगी क्यों क्योंकि नीचे गिर रहा है और टाइम कितना है दो
This
टू
is
स्क्वायर है तो देख
-10 पकड़ लेता है.
हाँ तो माइनस माइनस कैंसिल और कितना है हाइट कितना चलाइए 20 मीटर्स ऑलमोस्ट
हाँ.
ठीक तो ये हाइट मिल गई तुम्हें कितनी 20 मीटर तो
20
बेसिकली
मिल गई.
ये जो लेंथ है वो मिल गया ना तुम्हें
तो वो रिमेनिंग लेंथ तो 30 होना चाहिए.
बस रिमेनिंग लेंथ कितना है 30 मीटर्स बट स्टिल वन थिंग इज लेफ्ट टू कैलकुलेट व्हाट इज दैट
Radius.
Radius. This is 40, this is 30, so radius is 50 directly. No problem with that, right? Isn't it? Do we know the
हाँ.
velocity over here of this ball right now?
नहीं, यहाँ पे velocity भी लो लिखा हुआ
Velocity हमें निकालनी होगी ना फिर. Velocity कैसे
है.
निकालेंगे?
निकाल दी.
V is equal to U plus AT.
80.
Again, downward velocity तो minus V, initial velocity is 0, acceleration minus G into time 2 seconds. तो velocity भी कितनी आई? 20 मीटर पर सेकंड. Are you able to get me or not? तो यहाँ पे वेलोसिटी मिल गया अब ये 30 है ये 40 है तो दिस एंगल मस्ट बी 37 डिग्री और नॉट रिमेंबर दैट द अपोजिट ऑफ 3
Yeah.
4 if base is 4 perpendicular is 3 then the angle is how much 37 are you able to get me
37.
so this angle will be how much 53
Yeah.
so velocity के दो कंपोनेंट आ गए v cos 53 and v sin 53 are you able to get me? So now you got me. It was a tricky question or not? But a nice one, isn't it? V sine 53 divided by R. So
Divided by R.
V is 20, sine 53. Look over here, sine 53 is once again 4 by
4 by
5.
4 by 5.
4 by 5. Radius is 50. 0, 0, cancel. 8 by 25.
Right होगा. Radius per second.
Radians per second. Are you able to get me or not?
Yeah.
Totally clear?
हाँ.
So mention this in a good way in your notebook right now. Okay?
Yeah.
Yeah, very fast.
So I already know.
You have already written now. Can I move ahead then?
Yeah.
Yeah. So here now the observer was fixed, but still my even it is possible that observer can also move, na? Yes.
Move.
So
Yeah.
last
As in like moving the head or just
no
moving
no
the
no
body.
means like let's suppose if there is a KTM wala guy, let's suppose two buses are overtaking each other. There are two buses overtaking each other and one guy from the window is trying to look so once again when this bus will try to overtake this person will rotate the head or not
Yeah.
but at that time that person has also some velocity in forward direction But then how you are going to define omega with respect to that, that's a big question or not. So this is called basically, for that case, the omega is defined in a some particular kind of sense. I'll show you how. Omega is written as velocity of particle perpendicular minus velocity of observer perpendicular, both perpendicular on my radius. Are you able to get me or not?
Okay.
Omega means angular velocity of particle with respect
But
to.
are we taking the relative velocity
Yeah,
like
when
that
the
particular?
both the particle starts to move, we need to consider their relative velocity. That also must be perpendicular on radius. Are you able to get me or not?
समझ में आया।
समझ में आया?
और जब उल्टा होगा ओमेगा ओपी तो
हाँ,
माइनस
तो
ओमेगा
ऐड हो जाएगा।
ओ माइनस
मान लो
तो
जैसे,
फिर
I'll give you one question. Based upon that question, you will be getting it in much more perfect way. These things are basically numerical ways. Are you able to get me or not? Theoretical way I'll teach you.
या
But these numerical ways must be done through numericals only. So let's suppose this is A, this is B. A was going with 10 meter per second at an angle of 37 degree, and B was going in this particular direction. Okay, one minute. In this particular direction with a speed of 20 meter per second at an velocity of something called as sorry, at an angle of 53 degree. The distance between A and B is mentioned already, that is given as 100 meters. Okay, the question arises is find omega of B with respect to A. The question is find omega of B with respect to A.
ओके जस्ट 1 मिनट
अच्छा, इसकी रेडियस पहले बता दो कितनी है।
रेडियस
हम्म, इस केस में रेडियस क्या मानेंगे हम? अच्छा, यहाँ पे जैसे जैसे बी है हम और ए हो गया, तो बी मेरा पार्टिकल बन गया, ए मेरा ऑब्जर्वर बन गया ना। तो
हाँ
लाइन ज्वाइनिंग बी एंड ए की लेंथ कितनी है? 100। तो रेडियस की लेंथ कितनी है यहाँ पे? वंस अगेन
रेडियस तो 100 ही होना चाहिए
100 meters, बस that's all, that it is, radius is 100 meters. Now you do the next, take your time and do.
तो यहाँ पे बी बी पार्टिकल हो गया और ए ऑब्जर्वर हो गया
Hmm. Are you able to do it?
क्या है जस्ट 1 मिनट
Hmm.
says 0.1 radians per second
We'll check. So omega of B with respect to A, I'll write it as what? Velocity of B perpendicular minus velocity of A perpendicular divided by radius, or isn't it? This will be my equation or not?
yeah
Then these velocities will have two components. One is 10 cos 37. This one is 10 sine 37.
हाँ जी
And then this is 20 sine 53. And this is 20 cos 53. तो हमें रेडियस के ऊपर परपेंडिकुलर वेलोसिटीज माननी है ना? तो VB
हाँ तो साइन
परपेंडिकुलर
का कॉम्पोनेंट लेना
लेना
चाहिए
चाहिए, तो 20 sin 53 minus 10 sin 37 डिवाइडेड बाय 100, यही तुम्हारा ओमेगा होगा। So
Yeah,
20
right.
sin 53 is how much?
4/5.
4 by 5 minus 10 sin 37, 3 by 5
3/5.
divided by how much? 100. I
100.
think this is the step you did now. How much you are
Yeah,
getting?
I did. 60 minus 6. Which is
16 minus 6, that is 10 by 100. So it is 0.1 rad per second. Are you able to get me or not? Easy peasy हुआ या नहीं हुआ?
हाँ
हो गया ना?
I got
So
it.
this was all about omega, how it is related with velocity, how it is related with theta. We'll see now. Okay. So now we are going to enter into the territory of differential equations and all. ठीक है. तो basically if I just tell you that omega या फिर बोल सकता हूँ कि theta varies like t square plus 2t, then find omega at t is equal to 2 seconds. So basically you can do the differentiation and you can
So
replace
differentiate करके t का वैल्यू 2 से
करके
तो
इस
हाँ
तरह, हाँ तो इस तरह के क्वेश्चन बना ही सकते हो आराम से, है ना?
हाँ
आराम से हो जाएगा।
हो जाएगा.
Sorry. Do you want to do this question or should I skip it?
You can skip it.
Okay.
I
So,
like to do this stuff.
so now basically I'll jump onto that particular thing which is very, very important to us and which is going to be the most important tremendous problem. And that is called as something called as inertial frame and
Yeah.
non-inertial frame. ठीक है. So basically if you would have been in my classes I would have taken one lecture only for this topic, but I'll digress it in a very short form so that we are not going to derive anything or something like that. Okay. अच्छा, अब एक एग्जांपल बताओ, जब तुम बस में बैठते हो और जैसे ही बस आगे की ओर एक्सेलरेट करती है तो तुम कहाँ चलते हो? तुम पीछे की ओर धक्का फील करते हो या नहीं करते?
हाँ पीछे
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 फील
का
करते
धक्का
हो।
फील कर.
अच्छा देखो, ये जो पीछे धक्का, क्या मेरा ऑब्जर्वर बस में है तभी फील कर पा रहा है? अरे यू गेट मी?
हाँ
अगर
मतलब
अगर मैं उस ऑब्जर्वर को
हाँ
ग्राउंड पे रखता हूँ, अगर मान लो उस गलती से ऑब्जर्वर को कहाँ रख दिया मैंने, ग्राउंड पे, तो क्या वो ऑब्जर्वर धक्का फील करेगा क्या?
ग्राउंड मैंने किसका ग्राउंड
मतलब जैसे,
बस का ग्राउंड.
नहीं, मतलब मैं I'll do that. I'll just write this. So this is my straight track. ठीक. यहाँ पे एक अच्छा सा एक ट्रॉली चल रहा है, एक ट्रॉली है. ठीक है. उस ट्रॉली के ऊपर एक पर्सन यहाँ पे खड़ा है, बीच में, है ना? एक पर्सन ग्राउंड पे ऐसा खड़ा है. ठीक. अब ट्रॉली को अचानक से मैंने एक्सेलरेशन प्रोवाइड किया तो क्या ये पर्सन पीछे की ओर धक्का फील करेगा या नहीं करेगा?
हाँ पीछे धक्का फील करेगा.
अब देखो, ये ऑब्जर्वर वन है, ये ऑब्जर्वर टू है, कौन सा धक्का फील करेगा, फर्स्ट वन या सेकंड वन?
सेकंड वाला.
सेकंड वाला ऑब्जर्वर फील करेगा. मतलब ये ऑब्जर्वर उसी फ्रेम में धक्का फील कर रहा है जो ट्राई कर रहा है एक्सेलरेट करने का आगे में,
हाँ
है कि नहीं? आर यू एबल टू गेट मी
हाँ
और नॉट? तो इसका
यस.
मतलब इस पूरे कॉन्सेप्ट को डाइग्रेस करने के लिए हम लेकर आते हैं बेसिकली द अंडरस्टैंडिंग ऑफ इनर्शियल फ्रेम एंड नॉन इनर्शियल. तो अगर मान लो, अगर एक ऑब्जर्वर बैठा हुआ है किसी फ्रेम में, इफ द फ्रेम in which observer is sitting and that frame is moving with constant velocity, that frame is either at rest or moving with constant velocity. ठीक है. क्या मैंने बोला कि अगर तुम्हारे पास कोई भी फ्रेम हो जिसके अंदर क्या बैठा हो, ऑब्जर्वर बैठा हो, क्या बैठा हो,
ऑब्जर्वर.
ऑब्जर्वर, देन दैट फ्रेम, अगर मान लो वो फ्रेम अभी रेस्ट में है या फिर कांस्टेंट वेलोसिटी के साथ मूव कर रहा है, तो देन दैट फ्रेम will be referred as that frame with respect to that observer will be referred as inertial frame, will be called as inertial frame. Are you able to get me or not? This is clear? मेरी बातें समझ में आ रही हैं? ठीक है. So this is the main point, major point of importance with respect to or importance of our inertial frame कि जो भी फ्रेम होगा वो कैसा रहेगा, या तो रेस्ट में रहेगा या फिर क्या करेगा, कांस्टेंट वेलोसिटी में मूव करेगा, है ना. लेकिन वो किस चीज के रिस्पेक्ट में, तो ऑब्जर्वर के रिस्पेक्ट में. आर एबल टू गेट मी और नॉट? ठीक है. और नहीं नहीं नहीं, देखो इसमें इफ द फ्रेम इन विच ऑब्जर्वर इज सिटिंग लिखा हुआ है. समझ में आई बात, है ना. और नॉन इनर्शियल फ्रेम क्या है कि जब भी इफ द फ्रेम इन विच observer is sitting, observer is sitting, and that frame moves with constant velocity, and that frame moves with, sorry, constant acceleration, then this frame will be treated as non inertial. तो देखो तीन ही चीज हो सकता है, या तो फ्रेम रेस्ट पे रहेगा, या फिर कांस्टेंट वेलोसिटी के साथ मूव करेगा, या फिर क्या चीज के साथ मूव करेगा, एक्सेलरेशन के साथ. आर यू एबल टू गेट मी और नॉट? है ना. तो जब भी वो रेस्ट या कांस्टेंट वेलोसिटी के साथ मूव करे तो वो कौन सा फ्रेम उस ऑब्जर्वर के लिए कहलाएगा, इनर्शियल. लेकिन जब भी वो एक्सेलरेशन के साथ मूव करेगा तो उस ऑब्जर्वर के लिए वो फ्रेम कैसा बन जाएगा, नॉन इनर्शियल. आर यू एबल टू गेट मी और नॉट? इज दिस क्लियर और नॉट? तो देखो इसमें अब एक प्रॉपर्टी आती है कि इनर्शियल फ्रेम में न्यूटन्स लॉज आर वैलिड. ठीक है. एंड नॉन इनर्शियल फ्रेम में न्यूटन्स लॉज आर नॉट वैलिड. Then the question arises, then sir, how come we can solve basically the equation of motion, how the particles are moving in non-inertial frame? So for that, the people brought one technique, how to connect these two. So basically, in non-inertial frame, we bring the concept of pseudo forces. Are you able to get me or not? स्यूडो फोर्सेस क्या होते हैं? सो लेट सपोज बेसिकली, क्वेश्चन क्वेश्चन नहीं, मतलब ये समझने वाली बात है कि अगर कोई भी ऐसा फ्रेम है, ठीक है, फ्रेम इन द सेंस कि कोई भी ऐसी ऑब्जेक्ट है इन विच लेट सपोज दिस इज अ स्ट्रेट पाथ, एंड देन देयर इज अ बस व्हिच इज गोइंग, ओके. What is going? Basically I have my bus which is going, and that will bus has some kind of acceleration a during that time. Are you able to get me? Then whichever mass is present over here, ये जो भी mass, basically this mass is acting like an observer in this particular kind of frame or not. So does my mass m is present in non inertial frame? Okay, so then at that case, if it is, if there is any kind of mass is there in the non inertial frame, then it will feel the pseudo force, and that direction of pseudo force, direction of pseudo force will be opposite of original acceleration. Is this clear or not? तो डायरेक्शन ऑफ स्यूडो फोर्स कैसा रहेगा, हरदम ऑपोजिट ऑफ ओरिजिनल एक्सेलरेशन रहेगा. और दिस इज द प्रॉपर्टी ऑफ नॉन इनर्शियल फ्रेम. द ऑब्जर्वर इटसेल्फ फील द फोर्स. आर यू एबल टू गेट मी और नॉट? ओके। तो देखो मतलब बहुत लोग सोचते हैं ना कि अगर नॉन इनर्शियल फ्रेम है, मतलब नॉन इनर्शियल फ्रेम है, तो ग्राउंड वाले ऑब्जर्वर के रिस्पेक्ट में बेसिकली स्यूडो फोर्स आता है, बट दैट इज इनकरेक्ट। इट कम्स विद रिस्पेक्ट टू द सेम ऑब्जर्वर इन द सेम inertial frame, because this observer is now not following Newton's laws. So basically, to make it follow Newton's laws, we put the pseudo force in the backside in that particular observer. Are you able to get me or not? मेरी बातें समझ में आ रही है क्या?
हाँ।
ठीक है. So this was all the concept of inertial, non-inertial, omega and all, and how to relate angular velocity and all. Okay. So basically almost it is 11:45 over here, right or not?
Yeah.
What's the time over there?
It's 10, 10,
10 only.
10, 10.
10, 10. Okay, okay, okay. So basically I'll just stretch this 45 minutes as extra class another day. I came late because of traffic and all. So tomorrow there will be a class. Tomorrow you do not have any kind of classes, no?
No, no, no.
And your holiday starts from
Holiday is from, yeah,
when?
8, 8,
Hmm.
8 September.
That's great. Till that time I'll be shifted in my new home perfectly. Okay. So I'll be taking the classes before that, but in that new home all the facilities are there, Wi-Fi and all everything. So that will be very great thing. Okay. So I'll have completed till inertial and non-inertial, and then I'll relate this with centripetal and centrifugal tomorrow. Okay. So did you guys did something like derivation on based off on ER cap and ET cap, something like that? कुछ करवाया गया है
What
क्या?
is E? What is ER, ET?
ER and ET represent the radial direction and tangential direction. देखो तुम्हें दिखा रहा हूँ
No,
ये.
I don't think so. We did that.
ओके मतलब ये तुम बोलते हो ना कि एच सी वर्मा सर, एच सी वर्मा की बुक बहुत ही अच्छी बुक है. I'll show you this. So I'll be following properly the concepts of H.C. Verma, okay? Means the not the theoretical way. See, like right now I did the questions of omega, which were those interesting or not?
Yeah.
So these things are not available in any kind of book. Okay, these are my mind generated questions and all. Okay, so these kind of things I'll be doing with each and every topic, whichever you are going to follow. Means I'll be going into the depth of that what is actually happening and what is you are missing over there due to which you are not able to solve PYQs. Okay. So look over here. Basically, in the circular motion, there is a derivation which tells about centripetal and centrifugal force in a much more great sense. Okay. So this derivation from here till over here is there. So should I do it or should I just tell the results of this? What do you want?
Maybe if we do it and we understand that in a better way,
Yeah. So
I guess.
yeah, that actually the understanding of this centripetal acceleration comes from this particular line. Okay. This particular line tells us what can be the centripetal acceleration and centrifugal forces and all. So this thing appeared due to the derivation. Okay. So I think 15 minutes extra time I'll take for the derivation, and then I'll go to the concept. Basically, if you know this now, then the understanding of uniform circular motion and non-uniform circular motion becomes like a snap. Okay, so that thing I want to do. So I'll take 15 minutes extra, and then I'll just derive this relation, and then I'll move ahead. Are you able to get me or not?
Yeah.
Okay, so today I'm just taking a class of 1 hour 15 minutes. Tomorrow I'll be taking a class of almost around 2 hours and 15 or something like that minutes, okay? Or 30 minutes, 2 hour 30 minutes. Is that clear or not?
Yeah.
So is that possible or not?
Yeah. Okay.
Possible? No? So
No problem.
yeah, so we'll sit at 9 p.m. exactly, means mine 9 p.m., which is almost around 7:30 or 7:30 p.m.
Yeah,
over there.
it's 7:30. Yeah.
Yeah, so that thing you have got a benefit over there. That's so bad. Okay, so I'll do that tomorrow. Okay. So the concept of this non-uniform and this particular derivation, and then I'll apply this concept of inertial and non-inertial in that. Okay. Till that,
So like after today's class, what should I do?
what you wanna do? Mm, did you have completed this NLM friction part?
Yeah, I did. I mean, that was pretty good.
Okay. So did you completed objective one and objective two?
No, I didn't complete it.
So just complete this short answers by checking on Google also, and this objective one and objective two by putting the explanation on that. Okay. So just okay, just do one thing. Objective one and objective two. I'll give you the and then I'll give you the worksheets tomorrow. Okay.
Yeah, okay.
1 minute. Let me check with the worksheets. Okay. So I'll give you the worksheets tomorrow. Is that clear? And you just start with the book means till this week means till this Saturday and Sunday. We'll be going through the books and then upcoming Monday onwards, whichever day we'll be finalizing the classes and all.
So there's a tutorial, so this analysis section upcoming.
Yeah. So I'll be giving you the particular task sheet from upcoming week onwards. Okay. Where yeah means I'll assign you I'll just create a Google Classroom thing with you, okay, and then there will be assignments uploaded over there. You will have to just upload and submit it over there by scanning and all, or you can just send me the WhatsApp, sir, I have done this and all. Okay.
Yeah,
Okay, so that thing I'll make that for you. Okay.
yeah.
So I think that is fine. I think that is will be fine. Almost around I have, let me check, where is that file folder, need foundation. Almost. So from where you want the worksheet? Worksheet number one, worksheet number two, something like that, or uh, chapter wise worksheets you want?
Chapter wise, I guess.
Okay, so I'll start from beginning only. Okay, you do this objective one and objective two tomorrow, and then from Monday onwards, be prepared. I'll start from kinematics directly. Kinematics worksheets. Okay, and then you can ask me the doubts and all of at during that particular time. Okay,
अच्छा okay.
ठीक है, चलेगा?
हाँ,
चलेगा
चलेगा.
ना? ठीक है, तो मैंने प्लान तुम्हारा तैयार कर दिया है ऑलमोस्ट बाई tomorrow I'll be able to share the plan that what I am going to follow and how we are going to finish till rotational dynamics within this December month. Okay, I'll be finishing it till rotational dynamics within this December month, remember that. Okay.
Actually, in our school, they have started solids and fluid dynamics.
Mm-hmm.
So yeah, we also have to do that.
uh, I'll have to.
So you also have to do that.
Okay, in the month of
Yeah,
December.
yeah, not yeah, December.
In the month of December, solids and fluid dynamics.
Yeah.
Okay. Okay then. So, just did they have done SHM and waves and oscillation something like that?
No, they didn't do it. They haven't even started it.
Thermodynamics.
Nope.
Hmm. Okay then. So till rotational mechanics plus fluid mechanics, I can. Okay. See. Do you have any exams coming right now for the fluid dynamics and solid mechanical properties of solids?
Yeah, we have the finals, but that is in like Feb.
Okay. Okay then. So this month I'll be reaching till rotational. You are giving me a tough task, man. I have to put more extra classes. Okay, if you want to do the numerical analysis of all these things. Okay, we'll see. See, I'll complete. Let's do one thing. Let's just complete rotational dynamics with fluid mechanics and some basic properties of materials before only, and then gravitation, SHM, and thermodynamics in the particular month of January. Is that clear? Is that will be fine?
So,
Yeah, I
so
was.
what are we gonna do in
Uh-huh.
the next class? What
Tomorrow.
are we gonna do in the next
Tomorrow I'm going to do.
particular class?
Yeah, tomorrow I'm going to do that particular derivation only. You have to see that this derivation tomorrow. Huh. And then once again, nothing. Okay, just share. Can you share me your circular motion notes? What you have done, I'll be able to check that. Just little bit of photo. Yeah. Like
Before at now.
no, no, not now, not now. Like what is done in the school because I do not have idea what you have done basically. Okay.
अच्छा.
So should I consider because like your mom and sir, even Imran sir told me that do not consider her from scratch. You have to do it from little bit good level. So that's what. See, I'll just let us see tomorrow. I'll do this derivation. Okay, read this once. We'll check that. Then check uniform circular motion, non-uniform circular motion, and then this concept of centripetal and centrifugal force. Okay. After that, I'll be taking you away. Is that clear or not? Tomorrow your circular will be completed.
अच्छा. Okay.
ठीक चलेगा
चलेगा.
चलो फिर तो कल मिलते हैं अपन है ना
Yes, sir.
at 9 p.m. exact okay I'll be present
Yeah.
yeah I do not have any kind of work or something like that okay so tomorrow
Yeah.
okay, I'll be present by 9 p.m. Wow, wow. This is almost getting 12 over here okay so I have to go office tomorrow okay so I'll share all these things tomorrow dynamics of circular motion and all those kind of things okay ठीक है
Yeah.
ठीक चलो थोड़ा बाय बाय सी विल मीट यू टुमारो 9 p.m. okay